All right, let's talk about a huge problem. It's a problem every successful tech company hits sooner or later. What do you do when your data grows so massive it threatens to grind your entire system to a halt? Well, the answer is a super powerful, kind of complex, and honestly fascinating technique called database sharding. And trust me, by the end of this, you're going to get not just what it is, but why it's pretty much the final boss of scaling for the biggest apps out there.
So just picture this for a second. Your app is a massive hit. You've got millions of users signing up, creating just mountains of data every single second. And that one really powerful database server you have, the one that used to be overkill, yeah, it's now groaning under the pressure. Queries are getting slow, your users are starting to notice you've got a serious scaling problem on your hands.
Now look, your first instincts here are probably the right ones. You're probably thinking, okay, I'll just optimize my queries, or I know I'll add some indexes. And you should. That's absolutely the right first move. It's just good database hygiene. But when you're dealing with truly mind-boggling scale, you hit a point where you're just polishing a system that is fundamentally not built for that kind of load. You're not just tuning the engine anymore. You need a whole new car.
At the end of the day, the real problem is just physics. A single server, I don't care how powerful it is, has hard limits on its CPU, its memory, and its disk speed. Now, indexing and optimizing queries, that makes the server work smarter, for sure. But it doesn't change the fact that it's still just one server trying to climb an ever-growing mountain of data. Eventually, you just hit a wall.
This is where things get really interesting. To wrap our heads around this super complex solution, we're going to use a really simple analogy that makes it all just click. So forget about databases for a minute. Let's talk about pizza.
I want you to picture a pizza that is so enormous, it fills an entire room. There is no way on earth you could eat this thing by yourself. It's just too big. This giant, impossible pizza, that's our overflowing database. So what do? Well, the solution is so intuitive you don't even have to think about it, right? You can't handle the whole thing at once, so you partition it. You slice it into smaller, manageable pieces. Then you parallelize the work. You call over some friends. You give each of them their own slice to focus on. And just like that, an impossible task becomes easy because you've distributed the workload. And that, in a nutshell, is the core idea behind database sharding. We're just taking that simple, logical approach to eating a giant pizza and we're applying it to our massive database. So let's go ahead and translate this analogy into the real tech terms. And check this out. The mapping from our analogy to the technology is almost perfect. That giant pizza is your database. The slices, we call those shards. Your friends who are helping you eat, those are the individual database servers. And that rule you use to decide who gets which slice, that's the sharding key. It's a really critical piece of data, like a user ID, that tells you exactly which server a piece of information belongs on.
Now, this whole technique actually has a formal name: horizontal partitioning. You can think of it like taking a giant spreadsheet and slicing it up, not by its columns, but by its rows. We're literally splitting the table horizontally. So for example, users 1 through 1 million go to server A, users 1,000,001 to 2 million go to server B, and you just keep going. Each server holds a complete but much smaller piece of the whole puzzle.
So why on earth would we go through all this trouble? Well, the benefits are huge. When you want to find a specific user's data, you don't search the whole thing. You go directly to the one small shard that has their info, which makes reading data incredibly fast. Instead of searching a billion-row table, you're just searching a 1,000,000-row table. Same logic applies to writing new data. It's way faster. And all of this leads to much easier maintenance. I mean, upgrading or indexing a small, focused server is worlds easier than taking down some monolithic beast that runs your entire company.
Okay, but here's the catch. There's always a catch, right? Like any powerful solution in engineering, sharding is not a magic bullet. By solving the big database problem, we've actually created a few new, tricky problems for ourselves, and they require some very clever solutions.
The first major headache is trying to do joins across different shards. What if you need to pull data that lives on 2 different servers at the same time? You have to ask server A for its data, wait for the results, then ask server B, and then try to combine them yourself. That trip across the network is incredibly slow and expensive. And this is exactly why choosing that sharding key is so important. If you shard by user ID, for example, then all of a single user's data, their profile, their posts, whatever, all lives together on the same shard, which means you avoid those painful cross-shard joins for most of your common queries.
Let's jump back to our pizza party for a second. What happens if you've already cut it into 8 perfect slices for your 8 friends, but then 10 more friends show up hungry? Your whole system is inflexible. Reslicing the entire pizza or re-sharding the whole database is a massive, disruptive operation. You can't just easily add new servers on the fly.
And this is where some really clever engineering comes into play. Engineers have come up with brilliant algorithms to solve this exact problem. One is called consistent hashing, which kind of arranges servers in a ring, so when a new server joins, it only has to borrow a little bit of data from its next-door neighbor, instead of reorganizing the whole party. Another cool approach is hierarchical sharding, which is basically like saying, hey, this one slice of pizza is still too big, so let's just cut this one slice into a few mini slices, all without having to mess with the rest of the pizza.
All right, now for maybe the most critical question of all. If you've given a whole slice of your pizza, a whole chunk of your data to one friend, what happens if that friend drops it on the floor? I mean, if one of your database servers goes down, do you just lose a huge part of your user data forever? No, absolutely not. The standard solution for this is a really robust setup called master-slave replication. Here's how it works. For every single shard, you have one master server that handles all the new data being written. Then you have several slave servers that are just constantly making exact copies of that master. So reads can be spread out across all of them, but if that master server ever fails, one of the slave servers is automatically promoted to become the new master. It's crucial redundancy, and it makes sure no data is ever lost.
So we've seen the power, but we've also seen the complexity. And that brings us to the most important practical question of all. When should you actually do this? Because despite how powerful it is, sharding adds so much complexity that it should almost never be your first choice. You know, there's a quote from our source material that just nails this perfectly. The idea of slicing up data, simple, but actually implementing it in a live production system, dealing with consistency and failures and all the little edge cases, is incredibly difficult. It takes a highly skilled engineering team to pull it off right.
So here's the big takeaway. Before you even whisper the word sharding, you need to exhaust all the other options. Push your indexing and your query optimization to their absolute limits. And you should also seriously consider using a different type of database, like a NoSQL database, because a lot of those are actually designed from the ground up to handle all this sharding stuff automatically, behind the scenes.
At the end of the day, sharding is the solution for when you've outgrown everything else. It really is the final boss of database scaling. It gives you the power to handle pretty much infinite amounts of data, but it demands a huge investment in engineering complexity. So the final question really isn't just can you shard, but is your system and your team truly ready for it?